Okay, today is the class number 3, and in my last class, that is in class 2, I explained the ring substitution reaction of carboxylic acid. Now, the point which was left is that organic carboxylic acid, that is benzoic acid, does not undergo Friedel-Crafts reaction because of the fact that carboxylic group is deactivating group. In my last class I told you that it deactivates and it forms positive charge on ortho and para position, and Friedel-Crafts alkylation was actually like this. It was in first year, anhydride aluminum chloride, which is Lewis acid, and that Lewis acid takes one chlorine from that methyl chloride. Because it is electron deficient, 1, 2, 3, 4, 5, 6, there are 6 electrons, 2 electron is left to get octet. That's why it takes this chlorine along with bond. So you get what? CH3 plus AlCl4 AlCl4 negative, unstable one. This is actually electrophile, and that electrophile enters in the benzene ring. That electrophile enters in the benzene ring. Now, in case of Friedel-Crafts acylation or alkylation or Friedel-Crafts reaction, when carboxylic acid group is in the aryl benzene or aromatic benzoic acid, that deactivates and that part becomes electron deficient. So the electrophile produced cannot enter in this position due to positivity. And next reason is that aluminum chloride, which is Lewis acid, get attached with carboxylic group. That's why Friedel-Crafts reaction is not shown by benzoic acid or aromatic carboxylic acid. Next type of the reaction was left out, CH3COOH plus ammonia. This is very important reaction. Very often this reaction appears in conversion type of reaction, carboxylic acid plus ammonia. Simple NH3 get attached with this one, you are getting NH4 plus, and on heating water molecule released, H2O and H2O, there is one H2 left, so you are getting CH3CO NH2 amide. This is very important, keep it in your mind. Next one is again very important, third type of the reaction, say acetic acid plus Grignard reagent. Very important, this reaction is very important. Grignard reagent, earlier I told you this is plus and this is minus. I won't show you the huge mechanism or the way, but it is very simple. In case when Grignard reagent is made to react with carboacetic acid with carboxylic group, then this Grignard reagent acts as carbanion, and that carbanion abstract one hydrogen from simultaneously you are getting CH3, very important reaction, CH3 from Grignard R part, and H from acetic acid, acidic hydrogen, and I will extract that acidic hydrogen to get this, means you are getting methane, you are getting alkane. Very often this question comes in entrance exam. Next one, say CH3, C double O, C2H5, again Grignard, CH3, Mg, Br. Again, earlier rule is here. Let us arrange it. Without rule, you can't get the answer. Just you follow me, you can very easily get the result. This part withdraws, become minus, so along with minus, and this is plus, along with minus part, this part attached, you are getting MgBr, and here you are getting CH3. Am I right? Now C2H5 or MgBr released, you are getting CH3, C double bond or CH3. I am rubbing off the upper part. Now you see CH3, C double bond O, one electron being withdrawn, sorry, oxygen withdraw, more electron you get, withdraws electron from here, this become plus and this become minus. Another, with this, another Grignard reagent molecule is used. So you are getting MgBr earlier, you have added like this. Am I right? That was ketone. I think I have rubbed it earlier. CH3, C double bond O, C2, H5. Once again I am repeating. Here OMgBr and here CH3 from Grignard reagent CH3 MgBr. This is minus, this is plus, this minus, along with this minus, plus part adds, and this you are getting, this part is released, you are getting ketone, CH3 C double bond O, CH3 in one line to write, then you can understand. CH3 MgBr again. So this is minus, this is again plus, this is minus, this is plus when it is withdrawn. So you are getting CH3 C OMgBr. Just earlier I can't explain it once again. CH3 from this one, and that was earlier attached to this one. Now last part is very simple. Acid hydrolysis, you are getting CH3 COH CH3, that is alcohol. That is with Grignard reagent, when acetic acid reacts with Grignard reagent, you got alkane, and when ester reacts, you got alcohol. And next one is probably I have forgot to give you another reaction. That reaction is very important. Silver acetate or silver sulfur carboxylic acid, when reacts with this in presence of CCl4, the answer is CH3Br, alkyl halide. Again you will get this in alkyl halide chapter. Since it is carboxylic, salts of carboxylic, that's why I am using this reaction. And mind that this is very important reaction, Hans-Dicker reaction. Hans-Dicker reaction. So you have got two name reaction. If you can recall, you can find that one is HBZ reaction, HBZ, Hell-Bollard-Janicki reaction. Alpha hydrogen is replaced by halogen in presence of phosphorus and halogen. That was Hell-Bollard-Janicki reaction. Another reaction is Hans-Dicker reaction. Just to follow, keep your mind, bromine in tetrachloride and silver salt. Sometimes, to make you confuse in the exam, the question appears in this way. Silver benzoate or silver salt of benzoic acid, and you will be given bromine in carbon tetrachloride. Simple. Alkyl part, bromine, earlier reaction. Now benzene, bromine, bromobenzene. Amid this reaction, I am just another reaction I am showing you. At the very beginning of today's class, I told you that CH3COOH ammonia, that becomes CH3COONH4 positive, and on heating water molecule get released, you get CH3COOCONH2 amide. So likewise, in exam this question comes. This is phthalic acid. Phthalic acid. If you are given ammonia to give for the reaction, what will you do? Simple reaction, just as earlier I have told, a bit earlier I have told. Whole chemistry is the chemistry of reason. Am I right? And in the entrance exam, very often a lot of questions of assertion type of question comes. So if you do not have the concept, say Friedel-Crafts reaction is not followed by organic carboxylic or benzoic acid, what is the reason? One assertion is given, another time reason is given, you may not answer it. That's why I am explaining a bit in details. So here what's happened, when you give heat, water molecule from both the two water molecule released. So you are getting this. Again on further heating, no chance of water molecule, chance is ammonia. Chance is ammonia. So you see ammonia NH2 and one hydrogen, say from here if you release one hydrogen, H2 and one hydrogen NH3. So you are getting CONH. So this is CONH, CONH. So your starting material was phthalic acid. This is phthalic acid. If it is para position, phthalic acid. COOH. Starting from this, you are getting this. So you may be confused that in the classes always it is written that it is a conceptual organic chemistry and it is for board and entrance exam, NEET, JEE, like this. So your class is double. No, it is very conceptual class, and I told you earlier, I have shown you that this time this question comes. soda lime, and answer was like this, and you are asked what is the molecular mass of the substance formed if it is twice. Answer was 32. So it is normal question. And now I am telling, I know some of you are already passed out and some are going to appear in your final exam. So those who are passed out, they may ask one question and one question may come in their mind, that what is the use of conversion and why I am spending time. Yes, this year NEET 223 a question comes. If you recall, I am telling you, the question was bromobenzene, magnesium ether, dry ether. Answer A, acid hydrolysis. Answer B. What is the final answer? If you recall that one conversion was bromobenzene to benzoic acid. I did it earlier class in class 2, I think. So now I will apply once again. When there is bromobenzene, I told you last class, so you try to make it Grignard reagent, but here you are magnesium and ether, it is nothing but Grignard. You are getting this. After treating with this, you are getting A. Now acid hydrolysis, what certain? This is plus and this is minus, so that hydrogen will come here and OH will go with this part. So benzene H means your answer is benzene. Maximum of the student, I asked them the questions answer, they give the wrong reply. They can't. So you mind that each and every conversion, what may be the type, is also important for those who are aspirant of competitive exam. Now last part of carboxylic acid is uses. You don't leave this part, use. Methanoic acid, textile industry, rubber making, ethanoic acid, very good solvent, vinegar. One extra information I am giving you, 8 to 10% acetic acid is called vinegar. Short question comes in exam. Next, hex N16-dioic acid. Its another name is adipic acid. In conversion I have done. Very important one, and very often question comes. Its use is polymer science, polymer chemistry, it is nylon 6. One of the starting material is adipic acid. Sodium benzoate, very important question, very often asked in higher entrance exam. Sodium benzoate, this is very good food preservative. And fatty acid, in the very first class I told you what is fatty acid, and higher fatty acid is used for making soap and detergent. I gave you stearic acid and palmitic acid in my first class. Palmitic acid is and stearic is so this is all about the carboxylic acid. Now I am trying to give you some more information about if I want to solve this one in today's class, it will be a lengthy one. I don't want to make the class very lengthy, and you please try to keep it in your mind. I will explain it whenever I get time with the shortcut how to keep it in your mind. Aldehyde plus Grignard reagent, answer alcohol. Again aldehyde plus Grignard reagent, alcohol. If it is formaldehyde, if it is acetaldehyde, in second case 1 degree alcohol, 2 degree alcohol. I will show you in aryl halide chapter, first chapter. Carboxylic acid plus Grignard alkane, Grignard says CH3 MgPr plus chlorine or X2, alkyl halide, nitrile, very important, often comes in exam, plus Grignard reagent and ester plus Grignard reagent, again answer alcohol. But one of the very common one is Grignard reagent plus, in my, I told you NEET 23 today in my a bit earlier in the class question comes Grignard reagent. Last part was B, acid hydrolysis, give the answer. So Grignard plus water in presence of acid. What the answer? Answer is CH3 MgBr plus acid hydrolysis means water is in two parts. The rule is this is plus and this is minus. Plus will come here. You are getting again everything. So this is the part of Grignard reaction with some of the important compound. Last part of today's is very important thing you see. I will explain it. You please try to understand. This is very tricky question. Acidity, order of acidity. You can't explain. Maximum of you cannot explain. I will first explain, not today's class, some of the fact about orthopara and meta effect, and then you yourself can solve all the problem. Otherwise you will be confused a lot. You can't explain the acidity. Next one is this one, again acidic order, acidity order. Third one is lots of factor will play to explain this. Next one is this is the end of the today's class, and very shortly I am going to start the aldehyde and ketone, and I just advise you all, please go to the series 1, 2 and 3 one by one. You need not find out the textbook once anytime, you just go through one. Your concept will be very strong, and it's my assurance you can try to answer each and every type of question with this concept on carboxylic acid. Thanks a lot to you all for being in my class with patience. Yes, I am extremely sorry that I missed out some of the additional information on the class. It will take only 10 minutes more. Please be patient with me. So this is the continuation or last part of carboxylic acid, which I mistakenly missed in the class. Actually, tamarind contains tartaric acid. So I am very much interested to tell you that tamarind contains tartaric acid, which in general doesn't find in nature, and I am interested with tartaric acid. What is tartaric acid? Because this question very comes in exam, in your board or in an entrance exam. So this is tartaric acid. Tartaric acid, why it is of utmost important? It is in a carboxylic group. That's why the importance is that in exam it very often comes whether tartaric acid, which form of the tartaric acid is optically active. So I will explain it later on optical activity, but mind that it is tartaric acid and this form is mesoform. This is optically inactive because it can be cut into two equal pieces and one part overlap on another part. After cutting, if you place one part over exactly the same, that's why it is mesoform and this form is optically inactive. Later on, in other time I will explain what are the criteria for optically activity. So, second information is vinegar. Vinegar, this question very often comes, it is acetic acid. And third point is again important, where from you get vinegar? Bacteria, Acetobacter. It is a bacteria which converts this into vinegar. Third point is again important, very often comes. This question is related to first year, again related to second year. I don't know, have you done this one? Dilute means water is there. Final product. Acetylene, HgSO4, dilute sulfuric acid, what you will get? You can't keep it in your mind simply by learning by heart. Please follow the rule. Since it is dilute, there are water molecules and that water molecule in presence of acid backs up into plus and minus. So any part here and there, it's of no difference. OH part is here, say CH2 part is there. There is rearrangement. That part is very important. So you are getting CH3 and that part comes here. CH2 and H is here. This is unstable one. You are getting CH3 and this is single bond. That one goes here. C double bond O H. You never imagine that acetylene gives acetaldehyde, ethanol. Since I am concerning with carboxylic chapter, the last part will be simple oxidation. That part converts into COOH. CH3, CH3, CHO groups will become. So you have got ethyne to ethanoic acid. The scheme is very simple. Once again I am repeating. CH triple bond CH, Hg plus sulfuric acid in dilute condition. You are getting CH double bond CH2, one hydrogen here and OH here. You are getting this part is CH3 and this is O and this is H. CH3 CHO on oxidations, this CHO becomes COOH. Very simple. So no scope to learn by heart, no way you can keep it in your mind, just you follow the technique. Another very important and typical and tough tricky type of question appears. CH3 C double bond CH2 NBS. You will be asked to write the answer. If you don't have any idea regarding NBS, N-bromosuccinimide, you can't answer because there is a bromine. So a bromine will come in bromine. Where you will add the bromine? It is in allyl form. That carbon is allyl. So that type of reaction is allylic substitution reaction, and in aryl halide or alkyl halide chapter again I will explain. This is a peculiar type of reaction. It is free radical mechanism. CH2 Br CH double bond CH2. You can't imagine the answer simply by seeing the reagent. And in the very first class I told you that if you do not have idea regarding the reagent, you can't proceed for organic chemistry. So first you must have the sound and profound knowledge on reagent. So N-bromosuccinimide. Actually, what is N-bromosuccinimide? This is N-bromosuccinimide. 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 Where from it come? This is NBS. Where from it come? It has actually come from succinic acid. I am showing you a bit detail. Succinic acid. A bit earlier I told you the reaction of ammonia. Again you are using this one. CH2 C double bond O NH4. Ammonia get attached with this one. Ammonia get attached with this one. So you are getting CH2 C double O NH4. What's happen? You add up. You are getting water molecule from here. Water molecule from here. It get lost. CH2CO NH2. CH2CO NH2. Am I right? Now once again you heat. Now no chance of water, you are getting ammonia. NH2 NH2. From this you might NH2 1H ammonia. You release one ammonia. CH2 CO NH CO CH2 this. Now you add bromine in presence of sodium hydroxide. You no need to learn all this, just I am showing you what is N-bromosuccinimide and how it comes. CH2CO CH2CO NBr. So symbolically the answer is N-bromosuccinimide is this is N-bromosuccinimide. Or if you cannot understand anything, just NBS N-bromo. If you know there is bromo, if there is allyl part, in allyl part you make substitution. No addition is there. Mind that. Substitution reaction. Another information is lactic acid. Very famous acid, lactic acid, and that lactic acid is, just you keep it in your mind, nothing else for your understanding. This is lactic acid and this is chiral center, this is optically active. In other class I will explain you what is optical activity, when a compound be a chiral, how, what are the conditions for a compound to be optical actives. Just I have shown you the compound, you just try to keep it in your mind. Next one is again very important. You have got it, that compound CH3OH. Here acid, concentrated sulfuric acid. You can't recall what will be the reaction. Actually you see it is carboxylic acid and it is alcohol. And I explain it in details regarding esterification. Acetic acid and this, it gives ester. This is actually esterification reaction. You must understand this is acid and this is alcohol. Acid, alcohol in presence of carboxylic acid, alcohol in presence of sulfuric acid, concentrated sulfuric acid gives you ester. And this is OH CO CH3. that is methyl salicylate. It is important because it is called oil of wintergreen. In very higher exam, this question appears, and that compound is very important. You will find in other class. I will explain aldehyde and ketone, salicylic acid, salicylaldehyde. This you will get it later on. Okay. The last tricky question is, in the exam very often comes carboxylic acid is tolerance or Felix reagent, but acetic acid does not. Very often question comes. Then of fact, which of the things are being oxidized by toluene? In the very beginning, in my second class, if you recall that, I told you the toluene and Felling reagents are mild oxidizing agent, and these two reagents very easily oxidized carboxylic group into COOH. If you give toluene and Felling. But now fact, the question is carboxylic acid tolerance. You have not got here aldehyde, that will become COOH. The acid itself is HCOOH. It reacts with tolerance reagent, but if it is CH3COOH, it does not react. No response. Means that toluene pairing is a very important thing which is very often used with aldehyde and ketone. In aldehyde ketone chapter I would explain it in details that it always reacts with CHO and the CHO becomes COOH. If it is acid itself HCOOH, how does it react with tolerance? That formic acid, and but acetic acid doesn't. You can't understand it very easily, but very good explanation is that. Let us write carboxylic acid, formic acid, HCOOH. You please follow me the structure. C double bond O, H and H. This is formic acid. Just you follow. Otherwise, you learn by heart and you try to keep it in your mind, and in exam you will forget what is the reason. What is the reason it is reacted in presence of tolerance and this and that to give conduction water like this. But acetic acid does not. Why? Just you see the structure. In the structure, are you not getting carboxylic acid? A group. And another part, are you not getting aldehyde? Due to the presence of this CHO in formic acid, it responds to tolerance and phelix. That CHO for CHO. But in CH3COOH, you are not getting two groups. You are getting carboxylic. You are getting, if you take it in this way, ketone, and this part is carboxylic acid. Ketone and carboxylic both doesn't respond to tolerance and phelix until and unless if there is CHO group. So formic acid is responded by phelix and tolerance, but acetic acid does not. Thanks a lot for being the part of the last part of the chapter.